All right, folks, we are doing 16.2, and we're going to talk a little bit about the structure of the notes from 16.1. So, we are looking at confidence intervals, which is the first statistical procedure we're learning. This is the thing all statisticians do. They do a lot when they poll, for elections. All right, so the formula we're working with right now is to estimate a population proportion, pi. And the way we do that is we take a sample proportion, p hat, which you get from your sample, and then you're adding and subtracting a critical value, which is called z star, which we're about to discuss how to get those right now in 16.2. Then you multiply that by a square root p hat 1 minus p hat over n, which you just did in the previous problem. That is called the standard error. So a couple things I want to notate for you. All right. So the thing you're adding and subtracting from your p hat, everything after the plus or minus sign, is called the margin of error. I think of it as the amount of space you're allowing yourself to wiggle around your sample statistic. It's kind of like hedging your bets. This guy is called the standard error. It is how much we think samples of this size vary from the true population parameter. And we are multiplying that by this thing called a critical value. So I'm going to walk you through how to get that and what it means in a second. But together, when you multiply them, that makes the margin of error. Logically, when you do this, when you're doing a confidence interval, you start with your p hat, and then you're adding and subtracting your margin of error, and then you get an interval, a range of values. Margin of error is ME. So you're going to have your low value and your high value, and you don't have any feelings about which number is right. Anywhere in your interval is great. By the way, the p hat is called a point estimate. It's where you start estimating from. But the idea is that since your p hat's probably not exactly the same as pi, you're going to give yourself some space, some room to wiggle. Okay. So when you're done doing this calculation, you're going to be saying things like, I am 98% confident that you're going to put the name of the parameter, so the true proportion of all Americans who have TVs in their bedroom, that goes right there, is between your low value, what you got when you subtracted this guy, the margin of error from your p hat, and your high value. And I recommend turning these guys into percents, just makes it easier to read. So that's the structure. This is the math. This is the sentence. They go together. Let's get into how to get z star. All right, so what we're doing is drawing a normal curve. We're doing normal curve business. So we're going to be drawing a sketch of a normal curve. You're going to need your table of values for this. Go ahead and find it. The new online is actually a huge pain in the butt. So we're going to be doing chapter 12 business. We are sketching a graph where 98%, so we're going to talk about how you get 98% confident. That's going to generate this number. So you're going to put 98% written as a decimal in the middle of your graph. I'm going to add a couple more zeros because I'm going to be looking up on the table. So if I'm 98% confident, I'm going to start with my p hat and go a certain distance left and right from there. And I'm trying to figure out that distance right now. So what I'm going to do, I'm going to say this graph currently is incomplete. I'm missing 2%. 2% is missing both from the left and the right together. So if I cut my missing 2%, I'm going to have a 0.0100 here and a 0.0100 here. And now this graph makes sense. It adds up. Now to look up how far I have to go, I'm going to be looking up these two z-scores. So I'm going to be doing a reverse lookup in the table. I'm looking for not this guy. Now, if I shade what I'm thinking about, I'm thinking about the middle 98% of my data. Right? But what I'm actually going to look up in the table is the bottom left tail, because that's the only thing this chart can do. So I'm looking for 0.100. I'm finding what z-score that is. So I'm looking for point. So my choices. This one's closer, so I'm going to say this z-score right here is a negative 2.33. Okay. Now this graph is incredibly symmetrical. What's going to happen when you try to look this other one up, you're going to get a 2.33. I'm happy with this. If you want more details, to get this upper one, what you do is you add up this guy and this guy to figure out below this value what percent of your data you want to find. So 98% plus 1%, 0.99. I look up the 0.99. This one's a little closer, so this will be a 2.3. So just heads up, guys, that 98 is not what you're looking up, and it won't be, so be very careful with that. So this has 1% missing on the top. So be careful, this number is transformed, and the way that you transform it is you do 1 minus the confidence level over 2. That's what I got to get this guy. Cool. So what have I found out? I have found out that my critical value, the number of simulations I have to go away from where I'm starting to get 98% of my possible data values is 2.33. So critical value Z star, 2.33. I need to go 2.33 standard deviations away from the middle to capture 98% of the data. So when I'm 98% confident, I'm going 2.33 standard deviations away. So I would be replacing this Z star here with a 2.3. There is a way to do this on your calculator. I'm going to show you this, but it's a little dangerous because you have to make sure you do something with this 98%. It can't stay the way it is. So inverse normal, I have to do 1 minus CL over 2. So 1 minus 0.98 over 2 to get the 0.01. Inverse normal is in the following place. You are going to be using the distribution button, which is second bars. You go option 3, inverse normal. What happens here is you want to tell it the area to the left, so it's 0.01. You still have to do the sketch or think about it to get that number. So I'm asking, hey, what's the z-score if I have 1% left of that? And the answer is negative 2.326, which I round. So a couple things, guys. If you do it this way, it's going to give you the negative, but this is a quantity, left and right. So the critical value, I'm going to drop the negative and round 2.3. So that's how you do that with the calculator. If you want to double check that your work was good, recommend. And then you do the same thing again for 95%. So go ahead and sketch this guy, figure out what's missing in the tails, look it up, double check with the calculator. And then when you're done, at the bottom, copy the chart. Because the chart gives you all of these critical values, and they won't be changing. So use them.